Good day, everyone. Now, in this video learning, we are going to talk about probability of random variable. Now, we have learned in our previous video that a discrete random variable can be represented using a probability distribution indicating the probability function, and the sample space. And in this video learning, we are going to talk about probability of a random variable. And in this video learning, we are going to deal with our objective, and that is to compute the probabilities corresponding to a given random variable. And to start with our video learning, let us go with our recall of the previous lesson. Now, I do have here the discrete probability distribution. And we do have the random variables. We have 1, 3, 4, 5, and 10, and its corresponding probability. Now, what if we are going to answer, or we are being asked to answer the first question? What is the probability of a random variable 3? Again, what is the probability of a random variable 3? Now, in this case, looking in our given table, the probability where x is equal to 3 is equal to 0.20. I repeat, the probability of a random variable x is equal to 3 is 0.20. Now, what if we are asked to find for the probability of the given random variable x where x is equal to 5? Then the answer is 0.15. Okay? Now, from the given illustration, we can see and we can determine the probability of a certain random variable since we do have a discrete probability distribution. Okay? Now, I do have here a certain problem, and this is in connection to our new lesson. Now, what if a six-sided die was tossed 2 times? What is the probability that 3 will turn up once? I repeat, what if a six-sided die was tossed 2 times? What is the probability that 3 will turn up once? To answer with this problem, let us first provide our sample space or the list of possible outcomes. And we do have 1, 1, 1, 2, 1, 3, 1, 4, up to 6, 6. Okay. But in the given problem, we are just interested in determining the probability that 3 will turn up once. Okay? Therefore, I do have here already the listed outcomes as regards to the probability that 3 will turn up once. And what are those? We have 1, 3, 2, 3, 3, 1, 3, 2, 3, 4, 3, 5, 3, 6, 4, 3, 5, 3, and 6, 3. Therefore, we do have a total of 10 outcomes that 3 turn up once over 36 listed outcomes when a six-sided die was tossed 2 times. Therefore, our probability that 3 will turn up once is equal to 10 over 36. 10 as the listed or the total number of 3 that appear once when a six-sided die was tossed 2 times, then all over 36. Okay? But 10 over 36 can be simplified since 10 and 36 is divisible by 2. Therefore, our probability that 3 will turn up once is equal to 5 over 18. Okay? But what if we are not going to provide the sample space? How are we going to find the probability that 3 will turn up once without providing the sample space? Now, in this case, we can use the probability mass function of binomial distribution. And what is this binomial distribution? A binomial distribution is a probability distribution with only two possible outcomes, success and failure. I repeat, probability um, binomial distribution, I repeat, binomial distribution is a probability distribution with only two possible outcomes, success and failure. Meaning to say, what is the probability that 3 will turn up? And what will be the failure relative to the probability that 3 will not appear? And to guide us further with this concept, we do have the formula. The probability of a certain random variable is equal to the combination between n and the x multiplied to the probability of success raised to how many times it will appear, and then Q, the probability of failure, raised to n minus x, wherein P serve as the probability of success, the small p, okay? That is this one, okay? And then the Q is the probability of failure. And then what about the N? The number of trials performed during an experiment of getting X successes. Okay? Therefore, we do have the P, the probability of success, Q, probability of failure, and the number of trials performed during an experiment of getting X successes. And we have to go back with our example to utilize our concept about binomial distribution, that without any sample space or the list of possible outcomes, we can find the probability of a certain random variable. Going back with our previous example, what if a six-sided die was tossed 2 times? What is the probability that 3 will turn up once? And applying the concept of the binomial distribution, now we do have here the formula. First, we are going to get the probability of success. Now, in this case, the answer is 1 over 6. Now, remember, class, that in a given die, we do have 6 faces. We have 1, 2, 3, 4, 5, and 6. And our interest is to find for the probability that 3 will turn up once. Therefore, the probability of success that 3 will turn up is equal to okay, the probability that 3 will turn up among the given six-sided die is equal to 1 over 6. Okay? And then for the failure, the answer is 5 over 6, meaning to say, what is the probability that 3 will not appear? The answer is 5 over 6, which are the following: 1, 2, 4, 5, and 6. Therefore, the probability of failure is 5 over 6. The probability of success is 1 over 6. Okay? The probability that 3 will appear is 1 over 6. The probability that 3 will not appear on a six-sided die is 5 over 6. On the other hand, what is now our N? Since the number of trials is equal to 2, then N is equal to 2 because the die was only tossed 2 times. Okay? And then, how many times the 3 will turn up? The answer is 1. Okay, therefore, our x is equal to 1. Okay? And then, applying now the concept, by substitution, we have the probability that 3 will turn up once is equal to the combination of 2 relative to turn up once, multiply to the probability of success. We have 1 over 6 raised to 1. Okay, as you can see, times the probability of failure. Okay, and then that is 2 minus 1. But remember, you always have to provide here the open and close parentheses. Okay? Open and close parentheses. And then first, we are going to simplify this one, the combination. Okay? Now, this combination is equal to, we have 2 factorial all over, we have 2 minus 1, open and close factorial, 1 factorial. Okay, I repeat, this combination is equal to, we have for the numerator, whatever be our n, that will be n factorial, which is 2 factorial, all over the difference between n and x. We have 2 minus 1, open and close parenthesis, factorial, and then we do have the x, which is x factorial, and that is 1 factorial. Multiplied to 1/6 raised to 1 times 5 over 6 raised to 1. Why? Because 2 minus 1 is equal to 1. Okay? Now let's continue. Okay. Now, in our simplification or in our value, we do have 2 factorial all over 1 factorial times 1 over 6 raised to 1 times 5 over 6 raised to 1. And then, the 2 factorial implies that you have to multiply 2 times 1. And for 1 factorial, that is 1 times 1. Then 1 over 6 raised to 1 is 1 over 6. And then 5 over 6 raised to 1 is the same as 5 over 6. And then application of the multiplication for fraction, then we do have 2 times 1, 2 times 1 times 5, 10. 1 times 1 times 6 times 6, 36. Therefore, the answer is 10 over 36. And we can simplify this one into 5 over 18. Therefore, in our case, therefore, the probability that 3 will turn up once when a 6-sided die was rolled 2 times is equal to 5 over 18, which is similar in our previous illustration as regards to the given problem. Okay? Let's proceed with our next example. Now, in this case, our example for the given problem, we have 5 friends attended volleyball varsity team tryouts. What is the probability that only 3 will be selected if the probability of success is 60% and the probability of failure is 40% for each team? I repeat, 5 friends attended the volleyball varsity team tryouts. What is the probability that only 3 will be selected if the probability of success is 60% and the probability of failure is 40% for each team? Now, in this case, we are going to apply the binomial probability distribution to answer the given problem. And here are our given. We have the probability of success is 60%. Probability of failure is 40%. The probability of success is 60%. The probability of failure is 40%. Our n is 5. and then our X is 3. Okay, there are 5 friends, but only 3 will be selected. Okay, then let's proceed with the substitution. Here are the given values. And then by substitution, we do have now these values. We have the combination of 5 taken 3 at a time times 0.60, the probability of success raised to 3 because 3 will be selected or 3 represent our X. And then we do have the probability of failure. We have 0.40, then raised to 5 minus 3. And then we are going to get the value of this combination of 5 taken 3 at a time. Okay? And we have 5 factorial all over the difference. We have 5 minus 3, then factorial, then 3 factorial times we have 0.60 raised to 3 and we have 0.40 raised to 2. Okay? And then we have 5 factorial is equal to 5 times 4 times 3 times 2 times 1 all over. Now 5 minus 3 is 2. Then we do have factorial. Then bring down 3 factorial. Then times 0.60 raised to 3 and 0.40 raised to 2 or 0.60 cube and 0.40 square. And then, a 2 factorial is the same as 2 times 1, while 3 factorial is 3 times 2 times 1. On the other hand, the cube of 0.60 is equal to 2.16, while the square of 0.40 is 0.16. And then, application for the multiplication for the numerator and then the denominator, we have 5 times 4 times 3 times 2 times 1, we have 120. Then 2 times 1 times 3 times 2 times 1, we have 12. Multiply to 2.16 and 0.16. Hence, we have 120 divided by 12, we have 10 times 0.216 and 0.16. Therefore, the probability that 3 will be successfully selected out of 5 friends will be 0.3456. Okay? The probability that 3 will be selected out of 5 where the success is 60% and the failure is 40% will be 0.3456. Now, I hope you're able to learn with our discussion for this video learning that when you are going to get the probability of a certain random variable wherein there is 2 possible outcomes, success and failure, and without providing the sample space, we can able to find the probability of a certain random variable by applying the concept of probability mass function of binomial distribution. Remember, binomial distribution is a probability distribution with only 2 possible outcomes, success and failures. And with this, God bless everyone and see you in my next video learning with Bahagharing Lexi. If you are not yet connected in my channel, please do subscribe and ring the bell all. God bless and see you in my next video learning.